Good morning. We're going to take a look at writing slope-intercept equations today. Right? As you can see, as usual, there's a bunch of things that you could go through, videos and that sort of thing that you could watch. We're just going to focus our attention on the questions themselves and how to answer those questions. So let's see what we've got. The first one here is going to deal with the slope-intercept equations from a graph. Okay, so reading from a graph, there's two things we need. We need our slope and our y-intercept, right? So our slope, first of all, remember our slope m is equal to the change in y over the change in x. And specifically, when we record it from 2 points, that's y2 minus y1 over x2 minus x1. We can always find our slope using those parameters, right? Change in y over change in x can also be seen, especially graphically, as a vertical change, right? Where if it's going up, it's positive. If it's going down, it's negative. Over a horizontal change, where if it's going to the right, it's positive. If it's going to the left, it's negative. So that's a few different ways of interpreting slope. Our y-intercept b, well, that's given by the point 0b, all right, the value of y when x equals 0. All right, that's specifically what it is. Okay, so we can determine these quite easily just by looking at a graph. When we look at a graph, we see our x-axis down along here. Here's our x-axis. So when x equals 0, which is right in the center here, we look for our line. We see the value of y is 5. So we can determine right away that we've got the point 0, 5, which satisfies our y-intercept. Right, so that's the first thing that we can determine is our y-intercept is 5. Okay. The second thing we can look at here is we can look at our slope in two different ways. We can find another point that maybe matches what we're looking for. And you can see there's quite a few of them here. It seems to cross over quite a lot of times. If we were just to grab this point down here, we could then create a line down, a vertical line down, and a horizontal line across. And we could count the spaces, assuming that our scale is 1 unit each. So we see here we've got 5, 6, 7, 8. We're going down 8, so that's negative 8. And we're going across, what is this, 1, 2, 3, 4. We're going across to the right 4 spaces. So our slope m is negative 8 over 4. We could simplify that, of course, to being negative 2. Right? And this is quite obvious if we look at it at any other point in the graph. We can see we're going down 2 and across 1, and so our slope is 2 over 1. Okay, you could of course choose 2 points, any 2 points, and I encourage you to try this for yourselves. I'm going to choose, say, for example, this point here, which is negative 2, 9, any 2 arbitrary points, and we're going to choose this one here, which is 5, negative 5. And if you chose those 2 points as your x1, y1, and your x2, y2, that would allow you to use your slope formula to find your slope. You'd end up with the same number. So here we have an equation, y equals negative 2x. So for every 1x that we go across, it's going up, or it's going down 2 units, and we cross over the y-axis at 0, 5. So that's how you solve these slope-intercept equations from graphs. Okay, moving on, we're going to take a look now at the second one right down here. Okay, slope-intercept from 2 points. Okay, so once again, we're looking at, and let me highlight the idea here, that our slope m is the change in y over the change in x. And specifically, I pointed out in the previous example that this was y2 minus y1 over x2 minus x1. And our y-intercept b is the value of y when x equals 0. Okay, so those are 2 things that we need. This one's pretty straightforward to start with. We can assign this to be x1, y1, and we can assign the second one here to be x2, y2. And so we can solve our slope using those parameters there. So our slope m is equal to y2. Let me change color right there. That should be y2 minus y1. So where's our y1? That's this color right here. And that's going to be over x2 minus x1. All right, so color coding it there, you can see where we're needing to pull from. And so our slope m is equal to our y2 right here is a 7 minus, and our y1 is -1, so there's minus -1, so that's going to be, well, I'm going to leave in the -1 for now so that you see it. And our x2 is 4, and our x1 is 3. And so we have ourselves 7 plus 1 is 8, and 4 minus 3 is 1. So our slope is 8. That's the first thing we have. So our slope m equals 8. Okay, so we can start building this equation. So let's build the equation, knowing that our equation is y equals mx plus b, which is something that we've covered before. So I won't go into that right now. Okay, but knowing that our slope-intercept equation is y equals mx plus b, let's plug in first of all our slope. So now we have y equals 8x plus b. Okay, so whatever, we don't know what b is, but we do know what two of these points are. So we're going to choose one of these points, and we know that b will still be satisfied so long as we use one of these points. So we're going to plug in, let's say x2, y2, let's plug those in for x and y. And so we get ourselves 7 is equal to 8 times 4 plus b. Right, so just so you know where that comes from, this here is my y2, and this here is my y1. I could have this here is my x2, right? Y2 and x2. I could have chosen y1 and x1. I decided to choose y2 and x2 because there was no negatives in them. You could choose either. Just don't mix them. Right? Mixing them will give you the wrong answer. Okay, so let's solve this. This gives us 7 equals 32 plus b, right? And so solving for b, we subtract 32 from both sides, and that gives us negative 25 is equal to b. Right? So our b is negative 25. So finishing off our equation right here, so using all the information that we have, we're going to put this all together. We've got our m equals 8. We've got our b equals negative 25. So we get y equals 8x minus 25. Right? Those are the two values you needed, and you're good to go from there. So that's all there is to this one here. It's a little bit extra calculation that you didn't have in the previous one, because you don't have a graph to help you along. Right? But that's all there is to that. So solve the slope, solve the y-intercept given the slope. So you need the slope first. Plug in one of the points. So in summary there, let's summarize this real quick. Find the slope. Plug in a point for x and y, and then solve for b. And finally, use m and b to write your equation. And there we have it. Okay, let's look at this from the perspective of word problems. Right, so we're going to have some word problems right here. Okay, and finding the equations in the word problem. So there's a few things that you need to be aware of here when we're examining word problems. We need to be able to identify a couple of things. So the key ideas here is that we need to be able to identify for slope, right? A slope is a change, right? Anything that is changing changing with respect to something else. Examples of this might be miles per hour, right? And it's specifically the word per, right? Per is something that comes up a lot. Another word that comes up a lot is for each, right? That indicates a change in one thing with respect to another. And you can see that word coming into this question right here, for each, right? So we know that that's going to be a slope. Any verbiage that indicates a change in something is a slope, all right? So y-intercept. How do we determine what a y-intercept is? Well, a y-intercept is a starting point. Remember that the y-intercept is the value of y when x equals 0. So it's the beginning point or the starting point of any problem. All right. Now we'll be given two of three things. We may also be given a point. And so an xy point value will be given to us, and we'll see that when we have two numbers given. And those two numbers typically have a relationship with one another. So those are the things to look out for, okay? So in this case here, we've immediately identified our slope, right? All right, she's mowing lawns for a summer job. For every mowing job, she charges an initial fee plus $6 for each hour of work, right? So the initial fee in this context here would be the y-intercept, because that's the beginning value. Before she ever starts working, she wants so much of she wants the initial fee. But they're not telling us what the initial fee is. They are telling us, however, that our slope m is $6 per hour. All right. So $6 per hour. Her total fee for a 4-hour job, for instance, is $32. So it's saying, okay, well, for a 4-hour job, so for X number of hours, right? This $6 being $6 per hour, so you get 6x, right, in your equation from it. So for our x value is 4. The total fee is $32. So we can build an equation there. We don't have the y-intercept, but we have everything else. Okay, so we can say that 32, right, or y equals mx plus b equals 6 times 4 plus b, and we can solve for b again. So that's going to be 24. So 32 equals 24 plus b, and subtracting 24 from both sides will give us 8. So b is equal to 8. So with those two pieces of information, m equals 6 and b equals 8, we can write our equation, and our equation becomes y equals 6x plus 8. So she charges $8 to start with and $6 per hour after that. And that's how you solve all of those problems. Go ahead and give it a try for yourself, and reach out to me if you have any questions.